Okay, here's our video on cube roots. So we've done square roots, and we know we have this is the square root symbol, which is also called the radical symbol. So for a cube root, it's the same thing, but it has a little 3 there. So if I said the cube root of 8, so the cube root of 8, we need the same number times the same number times the same number 3 times. So for example, if I did 2 times 2 times 2, well, that's 8. So the cube root of 8 is 2. So now be careful. We did this. I showed you this in the last video. If I said 3 cube root of 8, square root of 8, that is not this. That's the cube root. It has a little 3, not a big 3. This is saying 3 times the square root of 8. This is saying the cube root of 8, which we know is 2. Okay, so, and by the way, there's more than cube roots. There's also the fourth roots. They'll have a little 4 there, or the fifth roots, and so forth. Sixth roots, for example. So we'll do stuff like that. But, so if I said, what is the fourth root of 16? What is the fourth root of 16? Do an equal sign, not approximate sign. So again, what number times what number times what number times what number 4 times is 16. That's 2, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So there's fourth roots, fifth roots, sixth roots, and you can have 100 roots, Babe roots. No. So we'll just concentrate on cube roots. So again, cube root symbol. So for example, what do you think the cube root of, let's say, 64 is? See if you can do that one. What is the cube root of 64? Okay, well, what number times what number times what number is 64? And it has to be the same number, just like square roots. It's 4, right? Because 4 times 4 is 16, times 4 is 64. So the cube root of 64 is 4. So remember when we did square roots, we had perfect squares. Well, we can also have perfect cubes. So a perfect square is 2-dimensional. Perfect square. So for example, 1 is a perfect square, but 2 is not, because it's a rectangle. But we know 4 is a perfect square, and you can get 2 on each side. 2 times 2 is 4. So we know 4 is a perfect square. And we know perfect squares, but we can also have perfect cubes. So let's say here's our cube, and if it's 5 foot on each side, remember cubes have to have polygons. The squares are the polygons. So here we have a perfect cube, 5 on each side, and we know that the volume of this cube is 125. Volume and cube roots are related, because we know if the volume is 125, because remember the volume formula is length times width times height, which is 125. So the cube root of 125 is 5. 5 times 5 times 5 is 125. So remember how volume and cube roots are related. Here we have our perfect cube. Now, one thing about cube roots that is different than square roots is that they can be negative. They can be negative. Remember, square roots can't be negative. The square root of negative 125 is an imaginary number. Remember we talked about that? And we'll just put that I there, imaginary. But the cube root of a negative number can happen. It could be, because if you use a negative 5 times negative 5 times a negative 5, you'll get a negative 125. So the answer here will be negative 5. So remember, negative cube roots can happen, but not square roots. So let's do another example. Let's erase this. Lost my eraser. What would be this answer? Try that. Okay, the cube root of negative 343 would equal negative 7. And why is that? Because negative 7 times negative 7 times a negative 7 equals negative 343. So again, we could use negatives with cube roots. We can also do fractions. just like square roots. If I say, what is the cube root of this? How would you do something like that? What do you think? Try it. So, you know you need a fraction. Well, we know the cube root of 125 is 5. So what if we say 1/5? Does it work? Well, what's 1/5 times 1/5 times 1/5? There's our answer. So the cube root of 125ths is 1/5. And if this was negative, it'll be negative 1/5. So we can do fractions. And remember how I said a volume is related to cube roots. See if we can do this question. A cube-shaped box has a volume of 260 cubic feet. What is the side length of each box? So here's our cube. Okay, doesn't have to be perfect. Okay, and we're saying that the volume is 216 cubic feet. Right? So what do we do? Well, we just get this cube root of 216. There's our answer. We'll know the length of each side. So what do you think it is? Okay, well, it'll be 6. Each side will be 6, because we know that 6 times 6 times 6 equals 216. So each length will be 6. Now, we can also do cube root equations. Cube root equations. So with linear equations, we have like x equals 5, for example. Well, here we have x to the third power equals 64. So that's like saying, what is the cube root of 64? That's basically what it's saying. What number times what number times what number is 64? And we know the answer, well, x will be 4. So if you see something like this, it's just saying that. Like if you saw something, x to the third power equals 125, well, we did something like this, right? That's saying what? Make the 3 better. Well, that's saying, what is the cube root of 125? So that's what a cube root equation looks like. And of course, they don't have to be integers, they can be fractions. A cube root fraction equation, saying the same thing. What is the cube root of that? 8 over 27. That is saying this. So what do you think it is? Now you should do the cube root of each number first. What's the cube of 8? What's the cube of 27? That will give you the answer. Try it. So basically, if you write this out on a quiz, you can say, well, what is the cube of 8 over the cube of 27? So we know that the cube root of 8 is 2, and the cube root of 27 is 3. So there's our answer. Let's see if it works. Okay, erase this. Still looking for my eraser. So if I had 2/3 times 2/3 times 2/3, we would get 8 over 27. So there's our answer. Okay. What if, now we can also do something like this. The cube root of 64, right? The cube root of 64, and then have it cubed. So first you get, what is the cube root of 64? Well, that's 4. And then 4 cubed is 64. You can do stuff like that. Let's do another one. What if we had, in parentheses, the cube root of 125 cubed? Well, we know that the cube root of 125 is 5, and then 5 cubed is 125. Okay, we can also do something like this. What if we had the cube root of 8 cubed? Like order of operations, we need to do what's inside the radical first. So that's actually saying, what is the cube root of 8 times 8 times 8? So what do you think that answer would be? So that's saying the cube root of 512, which we know is 8. fact, you don't have to do you don't have to do that much multiplication. Just look at the base of the exponent, and that'll tell you the answer. Now here is what we have: cube root table. See if you can fill this in. So we have if x is 3, well, x squared, 3 squared is 9. So what is 3 cubed? 27. Now this is not a 1. We know that 4 squared is 16. And 4 cubed is 64. And then what about 5 squared? Well, we know it's 25. We know that 6 squared is 36. What about the rest? Alright, well, we know this is 125. And one more. What do you think 6 cubed is? We did it before in the video. Okay, 216. So that's just a cube root table. Those are cube roots. Great job.